Hello, this is going to be a kind of a brief overview of my project that I worked on for my MIS class this spring. Just kind of a brief overview again. It's not anything in depth with the code because it took me a really long time to develop everything, so to explain it would take equal amounts of time. But I'll just kind of give you an idea of the process for what I did. So my idea for the project was to look at financial markets and see kind of what affects these financial markets. And you can look at technical indicators, or you can look at what I wanted to look at, kind of a functional or reactionary indicator of the market. And what I wanted to do was take the top stories that we see in the news and try to create a program that would in real time download that data as text, those articles, and then save them to files and somehow process them. And kind of a good metaphor is counting cards by using keywords to look at these articles and say what determines an article that's good versus an article that's bad, and how can we rank them, and if an article is really good, how can it be ranked versus an article that's a little bit less good, or an article that's even really negative or could affect the market negatively. So in the end, I was hoping to create a program that would kind of correlate to how the market would move in real time. So to go about doing this, I created a custom program in Java using Eclipse. You can see here. So I used JSoup, and it would go out to, So using JSoup, use one of the classes. So here's one of the classes that really is one of the working classes. Or one of the working methods, sorry. And then, so what's happening here is JSoup is using a loop that's in the main method saying, run this loop right now, and it will go out and connect to the internet, download this URL's HTML, all the code from the web page. And so this is a web page that I use. It's the Fox Business feed. It's one of 4 that I used. I've got AP from the Yahoo feed, Forbes, and the Wall Street Journal. So just the 4 most comprehensive, fastest updating RSS feeds that I could find for those news sources. So the program will go out to this URL, download all the web page data, and then use it in that get. And then we'll take it. JSoup has these really cool parsing where it can go through and find the title really easily. So that's what it's doing here for the title tag, and then takes the data from that title tag and creates an object. So then I can use the title and add it to an array list, and then save that array list as I'm running and after, so it knows which of these articles it's found, and then it knows not to download them the next time it runs. So it goes through, downloads all the web page data, stores it in a file, has a timestamp from when it found it. Oh, and it checks to see it found this article before. Adds a timestamp, adds a file stamp, and then adds, it was under the description tag. That's what the article text is under. So it stores that description information in this new text file that it's created with the name of the exact time that it's found it in milliseconds. So there won't be any overlap, and I'll know. I can easily parse later using just the title of that document containing all the article's text. And if you catch, and this just prints the Forbes business, will say Forbes business, and then the document title. So while it's running, it will tell me when it's found a new article, and then print out the name of the article, just because I thought that was interesting. It kind of tells me that everything's running correctly. Something I was finding, it would have some timeout problems. It would time out and then throw this really bad error, and it was kind of hard to correct. I'm sure if I had a little bit more time, I could probably do that, but that's one of the improvements that I would work on next time. So let's just run it here and see what happens. So how often should it loop? That's just how often should it go through and find and look for those 4 articles, those 4 sources of articles. How often should it check? So let's say 15 seconds. So what is the duration that the program should run? Self-explanatory. In seconds, let's say for 60 seconds. We're not going to let it run that long. We're just seeing. Please enter name for the new folder. So it's a folder containing all the text files. So let's say new. Continue last scan. So this is saying, do you want to go out and download the array list that's been used before? So it would kind of check. So if you had an error or you had to stop or something while it's running, it saves that array list. And this is the part where you say, do you want to retrieve that old array list and run your new articles against that array list to see if there's any duplication? So just kind of a backup. Let's say no, because we're just doing this for fun. Okay, so we got our 4 articles. Stock's rallying, good thing. Hopefully that's a good article. Yeah, and save those 4 articles. Had a new old monitor up earlier, so saved it in the new folder. Got all of our articles. So then, here's what kind of one of those articles looks like. JSoup does a good job getting rid of some of the HTML, parsing it out, but you still see, I mean, you got a strong tag, and those are all words that, I mean, aren't in the article. They aren't text that you would use to determine, is this a good article, or is this a positive, or is this a negative article? So next thing I had to do was, how do I get rid of all these tags and everything? Doing that, I used a program called Rapidminer. Rapidminer is a really cool program. It's super comprehensive. I spent hours and hours working to try to learn the program, and I'm still very beginner, very amateur in my knowledge. But yeah, it's extensive. You can do a ton of things with it, but what I used it for was text processing mainly. So here's the program that I would run to create my my 2 spreadsheets for all the articles. One of them, all the positive keywords, and a second that has all the negative keywords. So this one's positive, this one's negative. That's the break. So we have a process documents from files operator, and it's going out and finding the articles file containing all the article documents. and it's going to process those. So inside of this operator are more operators. You have an extract content, which is it's a web mining utility or operator, and what that does is it goes through and finds all the HTML. It parses the document and finds all the HTML kind of tags and everything that's HTML based and stuff we don't want, gets rid of it. Tokenize, gets rid of non-letters, parses it through and gets rid of non-letters. Filter tokens by length, pretty self-explanatory. Gets rid of everything that's not, it's between or not between 4 and 25 letters. So any really long URL or something that we don't want or don't need. And then transform cases, all the uppercase comes to lowercase. And so it uses that process document, processes it, and then that process document, this outer operator here, this one, that creates the example set that we are using. It does it once, and then this multiply breaks it and multiplies it into 2 example sets. So it's outputting 2, taking in 1. And then select attributes. I pasted my list of keywords here for all my positive and negative keywords, and it runs and finds just those attributes in each of these example sets, and then everything else just gets rid of. And then generate, it's just finding the total for each attribute. So each keyword, it's finding out how many times was it used, or not each keyword, but each article, how many positive or negative keywords are in the entire article, and then adds it up. And then write Excel, it just adds it to an Excel spreadsheet like I showed you before. And then you drag it to these results. So it's just a kind of a cool visual graphical way to use a program, and it does it all in XML. So if you really wanted to, you could edit any of the XML data that it's running on. So yeah. So what that did is create 2 Excel spreadsheets. It also, this is just the output inside of Rapidminer. Excuse me. So here we see, what is it? Which one is this? This would be positive keywords. So each of the articles, the article title is just the minute that it was found. And this is an older file set, so they're not the same type of name that I use now, which was the seconds. It's more accurate, but so here's the article name, and then here is each of the attributes or keywords that it's found or not found. So how many times was approved said it was used once in this article. And so it goes through and adds up for each line how many times were each of these used, and then adds them up at the end. So that's kind of a really cool way to use the program. It does it all at once. It's not, so I could just, if I found a new set, I could go to process documents and just add like a new list, add some new articles, just find the folder, select it, hit OK, and then hit play, and then it just does it all for me like it did before. So it's really cool, really easy way to do all that. It took a really long time to learn, I'm not gonna lie. So what to do next? So here's kind of an example of what one of the articles would look like. This is before the parsing of the keywords, so it still contains, it just gets rid of all those tags and everything, so it's just kind of a really simple, easy to see way. It's what the article would look like if you're reading it on one of your on their website or on an RSS feed. So next, I had to see, what do I run this against? Like, how do I, after I visualize this and I've got all the numbers and I can say, okay, it's decreasing here and increasing here, what do I run this against? So Google Finance has this really cool download. You can download all the data. So this one's for SPX, is a ticker symbol. It's the Spider Index Fund, and you can say it's in 60, which is just how many times per second. So, or how many seconds should it delay? Kind of like the program that I wrote. And so it's waiting 60 seconds at a time. So it's kind of every minute. So it downloads the data for an entire day, a day of trading, starting at minute 0, which is this, which is just a really precise date tag that we don't use. This would be 0, 1, 2, 3, 4, 5, and gets the date, the close, the high, low, open, and the volume. So really extensive data, and you can graph it out in a candlestick chart like you would see on Google Finance or Yahoo Finance or something. The problem with this was I couldn't find a source of real-time data. So if you wanted to do intraday trading data, you can find it and it's available, but it's very expensive. I guess you could write some kind of program to go out and query a website and find the current cost, but the data download like this, you can't really get intraday data that easily. So this is all historical, kind of. It's after the market is closed, so we're only getting this one day, but you can get multiple days, whatever. So we've got that data now. Next thing that I did, take everything and put it into Excel. So here is one of the two spreadsheets that we created with Rapidminer. You've got all your keywords and how many times they're used in each article. You can just kind of see. And this one's for the positive run and then the negative run. So you got all your negative keywords up here. Fall and guilty and declining, cut, controversy, and then breakthrough, buy, excite, all these really good keywords. So I tried to read through a bunch of documents, and the really positive ones pull out all the words that could only be interpreted as positive words or could only be interpreted as negative. Like sometimes you can say profit's a good word, but if it's used in the context of profits decreased this quarter, it's kind of a more negative use of the word. So I tried to use words that could only be interpreted as good in the eyes of a stockholder. So, I mean, I tried really hard to think of for each one, how could this word be used in the manner that doesn't, like, kind of opposite of how it's defined. And then only selected the ones that I really thought were strong. So here's all the file names. So 104 would mean the 104th minute of the day of trading. And then so this first one, it's kind of a little bit incorrect. There is an 89. This is just, I think, incorrectly counting. So we get rid of that row later on. But Actually, you know what? I think this one is good. But, so this one, it starts really high, even if it's used or not. I mean, in the grand scheme of things, it's going to start at 89 and go from there. So it's kind of a 0 point regardless. But you can see it's counting for each article. That's what the rows are. How many, in this case, positive keywords were used in each article. So 23, we got a strong, really strong one there. 33, pretty strong. And then some of them are smaller, either because shorter article, or hopefully there's more negative keywords and it can be kind of classed up as a negative article. So same thing for your negative. Here, this was again an earlier version, so I made them all negative because it's just easier to visualize as a negative versus a positive. More literal, I guess, but same thing. It's going through and counting. So I used a running total for each of those. So it'll add the positive and the negative and create a composite 71 in this case, and then as it goes through, it says 91 plus 19. So as each one of them changes, the composite will also change, and it has a running total. So a count is going up. We can see pretty frequently here it goes down, but I mean more often than not it's increasing. So we get a positive outcome. So from what we're seeing from the articles, good things are happening. So we should see, hopefully, good things are happening in the market during the same times. So kind of ran into a data issue here, having multiple articles for the same minute. So I just took the second one, since that's the kind of the ending point, combining both the articles. It takes both into account, and then it's the last one in each of them. And then the SPX data. So that's the spider index fund for that point in time. So for that 104th minute, it's what the spider was at that point, and then the total was taken from here. It's what the article total, running total was, and then here we see them graphed. So in blue you see the spider, and then red the running total. So it looks good. I mean, both are increasing. They're both increasing at a higher rate here, and they're both kind of stagnant here. But I mean, there is some very large inconsistencies. Correlation of 0.7, so it's, I mean, pretty strong. I was very confident. This is the first run that I had with the program, and it seemed pretty like it was proving my theory. But here's the second run. So here's the new file names in milliseconds. So it's actually not, I think it's in seconds since January 1st, 1970. So I had a fun time getting the year and time for that. So whatever, here's the time since open. So we have a few less articles than we did before, but hopefully I can, compare it and prove that it was similar. Down here is all the times for the spider for this day, and then I was able to use a macro here to just find the spider values for these times of the day. So it went through and found each of those. Thought that was cool. So we're getting, pretty positive running totals here, like we did before. There's a few articles that are pretty neutral at the end, but for the most part, it's on the up and up. You see that here in the blue in the chart. But when we compare it to spider in real time for each of those minutes, it's the opposite. I mean, it's not good. So correlation was negative, 86. Sometimes you can say, oh well, it's negatively correlated. It might, if it's still very negatively correlated, it might be still explaining this other explanatory variable, which is the spider here, the market. So that might be good at some point, but in the context that we're using it, it has to be positive. So it has to be positively correlated. Here we're seeing negative. It's the opposite of what we want. It just beats it up. So this was kind of a failure, while the other one was kind of a success. From here, this is a tiny sample size. I think this one's like a few hours, maybe, out of just one day. In the future, I'd really like to run it for an entire day, a few days on end for a few weeks, but it was finals week and dead week, very busy time for me, so I wasn't able to get it to run for as long as I wanted to. But in the future, that's something I'd like to get a larger sample size of points to kind of determine, is this functioning or is it not? But because we're kind of getting mixed signals here. Yeah, so that's the biggest improvement that I would like to focus on, but this is just kind of a brief overview of everything. Yeah, leave me comments in the comments section below the video. If you got any questions, try to answer them. Thanks.